Hello and welcome to the video of your first Java project at 42. Today we are going to discuss about object-oriented best practices and how to implement them in Java. The first thing you need to know is that Java is highly object-oriented and it tries to follow the paradigm by word. In the beginnings, object-oriented programming wasn't really well understood, but during time people worked on projects and from their mistakes they understood what works and what doesn't. And by this they tried to formalize this into object-oriented design patterns. We are going to discuss a little bit about design patterns and how they make our life easier inside OOP. And we are also going to discuss about a formalized way to present our project architecture to other developers to make it easier to understand through UML diagrams. UML stands for Unified Modeling Language. I'm going to show you here in my browser an image of a simple UML diagram. What you can see here is a visual way to express the whole workings of your project. We use here in UML diagrams these squares to represent classes. We use the links between them with some arrows, and we will see how these are interpreted. And we will see inside the boxes there are some stuff there, and you will get to understand what that stuff is. That represents the way that the classes are built internally. First of all, you need to see that there are multiple types of arrows there. For example, you can see here this type of arrow. This means inheritance, and what this means is that this type and this type inherit from this base type. You already know that in object-oriented programming, inheritance is one of the most important principles. Also, you can see here this diamond-shaped arrow, and this means inclusion. This means that these classes include instances of this class. UML is really used inside the software development teams because it eases the life of developers. Instead of trying to read the code, you just take a look at this diagram and you can get a feeling of how the project works, how the relationships between the classes are created. And it also makes it more unified, like the unified from the UML. The way that we present it to our stakeholders and to our colleagues, the way that we thought about the system. Well, only by using UML, this is not very helpful because you can use UML and all these best practices and still create a crappy system. And this is why we are going to discuss a little bit about design patterns. Design patterns are actually recipes that people found over time that really work in specific use cases. For this, there is one resource that I really recommend for you. It is called the Gang of 4 Design Patterns. You can see them. I have a link here, but there are many resources where you can find them. It's called like this because there were 4 authors of a milestone book regarding design patterns. And here are the most important patterns that you can check. There are multiple categories. You can see there are creational patterns, there are structural patterns, behavioral patterns, and each type of category contains multiple patterns. If we go, for example, and check how this is implemented, you will already see here a UML diagram. So it is really important that you understand how UML works and what every symbol in this type of diagram is in order to get a grasp of design patterns. Because you can read a lot about this, about a pattern. You can see here there are a lot of references, but yeah, you know, a picture is like 1,000 words, and here you can check exactly how this pattern works and what are the relationships between the classes when using this type of pattern. you will see in your project that you will also need to implement some patterns based on a UML diagram, but you will see this inside your in your subject. You will get into more details there. Today I want to show you what you are going to implement actually in this program. Maybe you already read the subject, but you know that you will need to implement an aircraft simulation program. And this program is going to work based on a scenario file. You can see this file here, and this represents the aircrafts that your system is going to simulate and the number of simulations that you will going to run this program through. You can see here on each line there are multiple elements. First, there is the aircraft type, then there is the name of the aircraft, and then there are the coordinates in a three-dimensional system. So this is the longitude, the altitude, and this is the depth. What your program is going to output is a simulation file that describes how the aircrafts interact when the weather is implied. This is the output file that you will need to produce. Now it's empty because I didn't run the program, but if we run it, you will see here what actually happened in the system. You see that we have here a message from the airport tower, and then you have the messages from each aircraft. Every time there is a change in the weather, the aircraft takes an action, whether it's going up or going down. I put here some funny messages just to see how the system works, but you can use whatever you want. Let's take a look at the project structure here in my IDE. You see that I used, let's close this, that I use multiple packages to have a nice structure for my project. I have here the base project, and then we have sub-packages here, one for the simulation part and one for the weather generation part. Inside the simulator, I put my aircrafts, and of course, you can see here, I have my main class, the simulator, which contains the main method. If you remember from the previous video, you see that we have this method signature, which always needs to be the same, and you can have multiple main methods inside your project, but you always need to specify which one you want to use when you run the project. What are the most interesting parts for this project are first the file manipulations. You will need to read from the scenario file, the one that you have here, and you will need to output in the simulation file. Working with files in Java is not the easiest that you can find. There are other programming languages that do it better, but this is the way that the designers projected it, so we are going to work with this. You can see here that for reading from a file, you will need a reader, which is a buffered reader in our case, where you need to specify the path to your scenario file. You can see here that I didn't hard code the name of the file. It's taken from the command line arguments. If you want to run the project from the command line, it's easy. You just type the run command and then put the arguments there. But if you want to use command line arguments from inside IntelliJ, you will need to put them here in the run configuration. If you go here in this menu, you can see that I specified the main class, which is the simulator. You need to be sure that you put the whole name of the class, because the name of the class is composed from the base name and the package where it is located. And here you have program arguments, and you can put here the name of the file. You will need to check the relative path. You can also put the absolute path here, but I use the relative path, and you will need to find out on yourself where the base path is for this project. What you need to take care also in this project is exception handling, because Java has a really good exception handling mechanism, and you need to treat also the error cases. You can see here we put some messages for multiple scenarios. In the case we couldn't find the file, or in the case you didn't specify anything in the command line arguments. Talking about the syntax of Java, I guess it's really familiar to you because it's a language from the C family. The constructs are the same. What you need to take care is about the coding standards. Java uses camel case for variable naming and uppercase for class naming, and also for methods the standard is to use camel case. You need to take care also of the indentation, but if you are really smart, you will see that IntelliJ takes care of this, but I will not tell you the shortcut for doing this, but this is a really smart program and takes care of all these problems. The repetitive instructions are the same as in C. You can see here a while construct, a for construct. There are different types of for instructions. You can use it the classic way with an index, or you can use the for each, where you go to the elements of an array or in a collection. In order to complete this project, you will need to use multiple classes from the Java standard library. You are not going to code everything from scratch. Java offers you a really big standard library, and it's also really well documented. If you want to see anything about a class from the standard library, I really suggest doing this online on the Oracle Technology Network, and for example, checking for the buffered reader. This is standard Java documentation. And I really suggest that every time you want to use a class from the standard library, you go here and check it. There's no better resource for this. And here you can find anything you want about this class. You can see the inheritance of this class. You can see that it inherits from the reader. You can see implemented interfaces of this class and other subclasses that inherit from the buffered reader. You can see here a short description, and here you can see a summary of the constructors and of the methods and the description of how they work. This is really a good resource, and I suggest that you use it. Now that we are here and we see this, the constructor summary, I'm going to show you how you create objects in Java. It's done through the new keyword. So every time you need a new instance of a class, you will use this keyword, the new, put in front of the name of the class, and this is going to return a reference to this class. One of the best parts of Java is that you don't need to take care of dead references like you need to do in C++, or you don't need to clean up the memory like you do in C. the virtual machine has a special program called the garbage collector, and every time it notices that a reference is not used, it's going to free up that memory space. This doesn't mean that you need to be not aware about your memory usage, but you don't need to take care to free it when you don't use it anymore. The garbage collector is going to take care of this, and it's going to make your life a lot more easier.